Hello guys, this is Paul McWhorter with TalkTechBoy.com, and we're here today with episode number 3 in our incredible new tutorial series where you're learning how to make your Raspberry Pi sing and dance. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually supporting or sponsoring this series of lessons, and we will be using their most excellent Sunfounder Ultimate Raspberry Pi Kit. And so what I need you to do is I need you guys to look down in the description. There is a link over to Amazon where you can pick this kit up. And believe me, your life will be easier and my life will be easier if we are working on the same hardware. And so the first few lessons in this series of classes, we focused on laying the foundation for the Raspberry Pi. But next week, we are actually cracking open this kit and are going to start using the components in it. So now would be the most excellent time to go ahead and order your kit. But enough of this shameless advertising. Let's jump in and talk about what I am going to teach you today. Well, let's talk about the first 2 lessons. If you remember in lesson number 1, I showed you how to get to first boot on your Raspberry Pi and then showed you how to make some modifications to the desktop so that it's not quite as lame as what it comes right out of the box. And so made some improvements to make it a little bit more visible, a little bit easier to use, made it a one-click machine, adjusted some fonts, and just made it a little bit easier to use. Then in lesson number 2, you learned the essentials of Linux, because if we're going to go in and start working with those GPIO pins and start coding things to make components work with those GPIO pins, you're going to need to know your way around the Linux terminal. If you haven't taken that lesson, make sure to go back and take lesson number 2. And then today, lesson number 3, in one session, we are going to learn the essentials of Python. And so my goal is to just sit down and learn enough about Python that you can make it through the rest of this class. So yes, this is a pretty important lesson. If you already have taken some of my Python classes and sort of know your way around Python, hey, still watch this video, maybe look in the comments or look in the chat. Be a resource for some of the new guys who have not done Python before. Okay, sounds good. So what I'm going to need you to do now is I'm going to need you to fire up your Raspberry Pi. And if you guys see me kind of looking confused every once in a while, I've got 2 mouses and it's very hard to operate with 2 mouses. Let me show you my studio here. I'll give you a quick studio view. I'll get out of your way. But if you see here, I have 2 mice. You're having trouble seeing them, aren't you? I have 2 mice. This one operates the Raspberry Pi, and this one operates my studio. And you can imagine trying to use 2 different mouse devices. You end up always reaching out for the last one. But I have digressed. Let's get the right mouse and let's come back over here and let's go to our Raspberry Pi, and you can see I have mine here running live. And then what I'm going to need you to do is I'm going to need you to come down here and fire up your Linux terminal. Fire up your Linux terminal like that. Boom, we have ours open and ready to go. Okay, now the first thing that we're going to learn about Python is we're going to kind of compare it to how it's different than Arduino, because a lot of you guys have used Arduino, and Arduino uses a compiled almost C-type language. And the way those work is you write all your code, you write all of your code, and then you compile it all at once, and then you end up with this machine code that is just a bunch of zeros and ones, and with that machine code, you put that down in the Arduino, and then it just executes that compiled code. Now, a lot of times I have people on the Arduino saying, oh, I downloaded it, now I've lost the program, how can I get the program back out? I'm sorry, the program doesn't exist anymore. Your program doesn't exist because you don't send your program down into the Arduino. You compile it into machine code and you send the machine code down into the Arduino. And if you didn't save it on your PC or on your IDE, then it is gone. Okay, so you write the program, you compile it, and then you run the compiled code. Very different for Python. Python is an interpreted language, which means it takes the commands one line at a time and then makes the machine code and then executes it. But every time you run it, it compiles it. Now, the downside of that is interpreted languages like Python are always going to be a lot slower than compiled languages like C. But a lot of times they're a lot easier to debug. They're a lot friendlier to work with. And so if speed is not your major issue, your major concern, then languages like Python are very nice. Now, Python is what is called execution ready. It means when you go into the Python interpreter, it is ready for a command and it's ready to execute that command. It is execution ready. You don't have to compile anything. Okay, so we're sitting here now on our terminal. How do we get to Python? Well, it's pretty easy. You just type Python like that and boom, you can see that it fires up a Python shell. You've got those three little greater than signs, and that means Python is waiting for a command. But wait, look at that. It tells us that we are running Python 2.7.16. Now, Python 2.7 is deprecated, and we really need to be on Python 3. Okay, I don't even know why Raspberry Pi is still delivering Python 2.7, but Python 2.7 is the default. And so if you just type Python, you're going to get Python 2.7, and you could get some unexpected results. And so first thing that you need to know is Raspberry Pi, as of the making of this video, comes with Python 2.7, and I think Python 3.6, and you want to be on Python 3.6. Now we're going to learn something. How do you get out of the Python shell when it is in the terminal? You do quit, open, close like that, and boom, you're now back to the $sign, which is, as you know from last week, the Linux command prompt. It is now ready. Linux is ready to do what you want. So now we're going to type Python 3, and this will run the 3.6 version of Python. We click enter and boom, I lied, 3.7.3. I thought it was 3.6, but I guess now they're delivering 3.7.3. By the time you take this class, it might be something else, but it is ready for a command. Okay, it is ready for you to tell it to do something. So let's just jump in and kind of start learning Python from the shell here. So we could do something like create a variable and assign a value to it. X equals 7. And then we could say something like y equal 2. Well, now I could say print X, and you can see it is 7, or I could print Y, and you can see that it is 2. Now, normally to show variables, you would say print, but to make things go a little bit faster operating from the command line, what I'm going to do is just say, like if I just type X and enter, it'll print it, or Y and enter, and it will print it. Okay, now one thing that you'll see here is with Python, you don't have to declare your variables. I could just say my car is equal to a Toyota, okay, and then I say my car, my car, and boom, it knows it's a Toyota. So it decided that my car should be a string because I set it equal to a string. It decided that X should be an integer because I set it equal to 7, and it decided that Y should be an integer because I set it to 2. Okay, but you could also see something, and this is what's really important, is because you think, wow, I don't have to declare my variables anymore. That's true, but you got to be very, very careful because you can get in a lot of trouble when you're assuming that your variable type is one type and Python has made it something else. And then there's just all types of very, very difficult things that can happen when that happens. Okay, but let's go along and let's play with this a little more. So let's say x is equal to 3, and let's say y is equal to 2, and now let's say z is equal to x plus y. Okay, and now let's see what z is. All right, well, z is 5. It figured that x is an integer, y is an integer. We're adding two integers. Let's make it an integer. All right, and so it made it 5. Well, what if I said x is 2.0, and then I said y is equal to 3.0, and then z is equal to x plus y. Now, when I put the point on there, I'm making it a float. It's like in the math world, I'm making it a real number, you know, not the rounded off numbers like integers, but make it a real number, the in-between numbers. And so when I put the point 0, it is sort of forced Python to make x a float. So now if I say x, it's a float. If I say y, it's a float. What do you think z is going to be? Okay, now z is a float because x was a float and y was a float. So that sort of makes sense. It sort of makes sense so far. But what if I said x is equal to 2, and then I said y is equal to 3.0, okay, and then I say z is equal to x plus y, and now I say z. What do you think it's going to make z? Because x was an int and y was a float. What's z going to be? Well, it made it a float. Okay, now that you wouldn't just absolutely positively know that for sure. After you think about it, you'd say, well, since it has a float in there, it better make the whole thing a float, because like then if y was 3.1, then the answer would have to be able to take the 0.1, so we better make the whole thing a float. Okay, but you see, Python sort of decides what to do, and sometimes it does surprise you. Okay, so you can see that we added those things. Also, like let's look at this. What if I said x is 3, and I said y is equal to 2, and then I said z is equal to x divided by y? In a lot of languages, that would make z 1, because z would be an integer, because x was an integer and y was an integer, and an integer divided by an integer, what it would make that, it would make it an integer, and instead of being 1.5, it would make it 1, because it would round it. But you see, even though x is an integer and y is an integer, Python makes x divided by y, it makes it a float, and so you get the 1.5 if you sort of see how that goes. Okay, we can also come in and, like, I could say my fruit, and my fruit could be equal to banana, like that. And now I could say, what is my fruit? And it is the string banana. Okay, it is the string banana. And so you see, we've looked at variable types of integers, we've looked at variable types of floats, and now we've looked at variable types of strings of characters. And so you use strings to contain words or anything else that are characters. So those are really your main ones. Now there's all types of other variable types, but the main ones you're going to use are ints, floats, and strings. Ints are the best to use if you're counting like 1, 2, 3, 4, 5. If it's going to be a round number, use an int. Ints are more efficient. If it might ever be an in-between number, then you need to use a float. Okay, you need to make it a float. And so let's think about grades. Like if you're averaging grades, well, if you're averaging grades, you could get a 69.5. Okay, so you better make grades floats. But if you are reading something from a digital port and it's reading a number between 0 and 1023, when you read read from a GPIO pin or read from a digital pin in Arduino, that is going to be an integer, and you better make it an integer. Okay, so what you want to do is you want to kind of keep track of your variable types and use the right type. Then strings are for anything that are not numbers. Anything not a number, you would make it a string, if that makes sense. Okay, now also, I don't know if I can do this. Let's see if I can clear. I know I can clear, but no, you can't clear there. I think I'm going to do this, quit, and then I am going to clear. And then I'm going to go to Python 3 just because I want to kind of start back at the top of the screen. I'm sure there's a way to clear it in Python. I just don't know what it is at the top of my head. So we have ints, we have floats, and we have strings. Now the other really big one, and we're going to be doing this throughout all of these lessons, you need to understand arrays. And an array is a list or a grouping of numbers. So now what I could do is let's make an array. I could say x is equal to a group or a list of numbers, and I start the array with an open bracket, and I could say I have the numbers 5, 4, 3, 2, 1. Okay, and so in this case, what I have is the variable x holds 5 numbers. So now I say, what is x? I look at it. Well, it is the list of numbers 5, 4, 3, 2, 1. But what you see is you really need to get at an individual number. So what I'm going to say is I want to get x in position 1. Okay, so if I tell it x in position 1, what number do you expect it to give me? I want the 1 position of x. You probably expect 5, but if you expected that, you would be wrong because it is 4. Because in the crazy world of programming, things typically start at 0. And so that 5 is in the 0 position. Okay, so the 0th element is 5, and then the first element is, that was bad. The first element is 4. And then what you can see is the 4th element is 1. Also, even though I have 5 numbers, there is no 5th position. So if I say x of 5, it gives me an error because with 5 numbers starting to count at 0, you end up at 4, right? You end up at 4. So there is no 5th number, and you get this error, index out of range. And this, when you're programming in Python, that's an error that you get a lot, index out of range. So when you see index out of range, you think, somehow I went one too far in the array, and I tried to read a number that's outside the index range of the array. Does that make sense? I hope that it makes sense. Okay, so we could also, I'm trying to think of what else we could do here. What we could also do is we could change something. I could say x of 1 is equal to 7. Now tell me what you think is going to happen if I say x of 1 is equal to 7. Now let's look at x. In that one position, now instead of having a 4, I now have a 7. So once I build the array, I can go in and I can put numbers in it. Once I build the array, I can go in and I can change the numbers. I can individually address them. Okay, I can individually address them like I just did. And so now I could say, what is x of 1? X of 1 is 7, which I just set it to. So that is pretty cool. Well, what if I set like x is an empty array? So now it knows that x is an array. And now if I just say, what is x? Well, it's the empty array. Well, now I want to put some numbers in it. So I'm going to say x of 0 is equal to 7, and boom, I get an error. Okay, I get an error. It won't let me put a number in there. So this is kind of one of the quirky things about Python is you can't just go in and add numbers to an array by indexing like you would expect. You can put a bunch of numbers in it first, like 5, 4, 3, 2, 1, like that. And then that was not good. X equal would be good. Okay. And now I could say, what is x? And then I could say, what is x of 1 or x of 2, let's say. And then I could say x of 2 equal 27. Okay, I can change it, and that works great to change it. But how do you build an array? How do you build an array? Well, I'll show you that. What I can have is, let's say that I have y. I've got to create y by making an empty array, and then I can say y dot append, and that is y dot append a what? A 4. Okay, and now if I look at y, look at that. It appended a 4. Now I could say y dot append, and I could append a 7 like that. Okay, and then if I say y, it's a 4 and a 7. Now note, when I say append, I'm using the smooth parentheses because this is a function call. I'm not using the square brackets, which indicate the contents are an array. I'm doing a function call, so that is why it is the around one. So I say y dot append of 7. Now I have 4 and 7. Now I could say y of 1 equal 23. and then I say, where is Y? Well, I can go change it. But the way I build it is I build it appending it, and then I can go in and change it by individually indexing a given element that I am interested in. So I hope that all makes sense. Now, you can also do multiple dimension arrays. You can do multiple dimension arrays. And so what I could say is X is equal to, that would be where it's not just a long list, but you could think of having rows and columns of numbers. And so let's start the array with an open. Okay, now I'm going to start my first row with an open, and I'm going to have 1, 2, 3. That is the first row. I end the first row, and then I put a comma, and then I open the second row, and that's 4, 5, 6, and then I close that, and then a comma, and then the third row I'm going to open is 7, 8, 9, and it doesn't have to be square. It doesn't have to be square. Okay, it doesn't have to be square. I'm going to have to move further out of your way, or you're fixing to start yelling at me, aren't you? Okay, and so that is the third row. Let's make a fourth row, and that would be 10, 11, 12, and then I'm going to close the row. I'm going to close the row, and now I'm going to close the array, and now boom. Now what is X? It is 1, 2, 3, 4 rows and 3 columns. Now what if I said X of 1 now? If I just said X of 1, it's going to give me what? It's going to give me the first row, which is the second row, right? It's going to give me the element 1, which is what? 4, 5, 6. If I said X of 0, it's going to give me the 0th row, which is 1, 2, 3. All right, so I can get individual rows. What if I want an element in a row? Like if I want the first element of the first row, I should say the 1 position. So I want row 1, not row 0, I want row 1, and then I want column 1. Well, what I would do is I would say X, give me row 1, and then give me column 1. And what would that be? Okay, well, this would be the 0th row, this would be row 1, and then this would be column 0, and this would be column 1. So it's going to be a what? It's going to be a 5. I should have asked you that and made you do that one. That would have been a good one to have you think through. So we can index things more than one. And you can even do more than that. Like, let's say that I had, let me do one more example. Let's say I had X is the first row. I'm going to start the first row. And now the first element in the first row is going to have 3 numbers. It's going to have 1, 2, 3, like that. Okay, now I'm going to go to the next element, and it is going to have 3, 4, 5. Okay, and now I'm going to go to the next element, and it's going to have 6, 7, 8. Okay, now I'm going to close that element. I'm going to close that row, and now I'm going to go to the next row. All right, and I will just, again, now I'm going to open the element, and it's going to be 2, 3, 4, and then the next element is going to be I did not do that right. Okay, I open the element, I have to open the row. So let's look at this again. And why is this important? Let me tell you where I'm going. That, like, if you have a picture or pixels, there are rows of pixels and there are columns of pixels. So that's a 2D array, rows and columns. But at a given pixel, if it's color, there are 3 numbers at that pixel, the R value, the G value, and the B value. So at each intersection of a row and a column, you have 3 numbers, and that's kind of what I'm trying to show you here. So we open the array, we open the row, and then we open the pixel. We close the pixel, we close the pixel, we open the pixel, we close the pixel. Now we close that row of pixels, we go to the next row, and then we open the row, and then we open the pixel, and then let me just do 2 rows. So I'll say 5, 6, 7. We'll go to the Munchkin me. 5, 6, 7, comma, or 5, 6, 6, comma. Let's say I need one more, so I'll say 7, 6, 5, like that. So now let's close the pixel, let's close the row, and let's close the array. Now, if I did my brackets right, this should take, and it did. Okay, now what if I say x sub 1? That's going to be the first row, and the first row has 3 pixels. Okay, if I want to look at an individual pixel, let's say I want to look at a pixel at row 1, column 2. So I'm going to say x row 1, column 2, and that is this pixel 765. It is the pixel 765 because it is the first row, which is, you know, the second one, and then it is the second, which is the third, and you end up over here at this pixel. Well, what if I wanted the red value of that pixel? Well, that would be x1, row 1, column 2, and then which value do I want? Well, the red would be the first one, RGB. R would be the first one, which would be 0. And then what do you expect here? What do you expect? You got a 7. Okay, does that make sense? So here, like, you can see that you can put pictures in these arrays, and that's why I want to kind of play with that a little bit, because a lot of Python, if you really understand these variables and kind of data structures, everything's going to be really easy. What else could I do? Let me think, make sure that I'm hitting the important high points here. Okay, let's say I could also say, like, I could say my fruits are equal to, I could put a string apple in the string, start a string orange, and then comma, and then start a string banana, like that. I'm going to close that string. I'm going to close the array, and I forgot my equal sign, didn't I? I forgot my equal sign. Okay, there. All right, so now what if I said, what is my fruits? Okay, apple, orange, and banana. Well, what is my one fruit? Well, I would say my fruits of 1, and that is orange. Okay, does that make sense? What if I just did something crazy, like I've got just a one-dimensional array so I can only use one index? What if I added another index? What do you think would happen if I added another index? Tell me, what do you think my fruits of 1, 0 would be? It would be 0. I mean, it would be O. Why? Because the one position fruit is orange, and then it says the guy wants to break it up further. I'll give him letters, and so O is the first letter in orange. And so what if I said like 2? That would be A, O-R-A. See, you can actually even index down inside of a string, which is kind of a crazy thing. So we have index, we've done arrays, we've done, okay, so let's play with this a little bit more. So what if I said print hello world? Okay, hello world is a string, right? Hello world is a string, and so now I'm going to print hello world, and it prints hello world, the string. Okay, what if I said MSG is equal to hello world? Okay, like that, hello world. And now what if I said print MSG? Tell me what you think it's going to do. Leave a comment. What do you think it's going to do? Print MSG, like that. If you had said it was going to print hello world, you would be wrong. Why? Because I didn't tell it to print. I didn't tell it to print the variable MSG. I told it to print the string MSG, so it printed MSG. Oh, you wanted hello world? Maybe you should have printed MSG, like that, and you would get hello world. Why do I do these things? Because, man, teaching real students in class, these are the mistakes I see over and over and over, and so I try to kind of make those mistakes. I have been like the munchkin for 20 minutes here, and I can't stand that. So let's come back to a more personal view of me, and not like the little postage stamp in the corner version of me. All right, so that's pretty good. Okay, so we have played around at the command line, but what do you really want to do? You really want to write a program, right? So let's quit out of this. Remember, it's quit, open, close, and like that. And now let's do an ls to see, let's see where we are, pwd from last week, print working directory. You can see that we're in my home folder, which is /home/pi, that I'm the default user, which the username is pi. And so that is where I am. If I do an ls to look at my directories there, I will have to get a little bit further out of your way. Okay, if you look at the directories there, you can see these various directories. I want to play with Python, so what I'm going to do is I'm going to make a directory, and I'm going to call it Python. And do you see how, like, the standard they're using is the folders, they start with an uppercase letter. I want to do that in that way. It's just always when I want to go to Python, remember, well, my directories start with an uppercase letter. So I'm going to make it like that. Make directory Python. There it is. And now I'm going to change directory down into Python. You learned this stuff last week. And now I want to write a program. Well, what are we going to use? We're going to use our friend that we learned about last week, Mr. Nano. And so the way I'm going to do this, I'm going to say nano, and then the file is going to be called hello world, and then .py, indicating that it is a Python program. So we could come up here, and now I could just say print hello, that's not good, print hello world, like that, and then close it, and then close it. And then how do I get out of here? I do a Control X, and then it says save modified buffer. I'm going to put a Y for yes. And then where do I want to save it? I want to save it as hello world.py. Now you could backspace and change that if you want, but of course I want to keep it that, and then there it is. Now what I could do is I could say Python hello world.py like that, and boom. Tell me what I did wrong, though. Why did I do it wrong? Because I know you're going to do it wrong. And so I'm going to make the mistake. Somebody tell me what I did wrong there. Okay. I ran it under Python 2.7 because I didn't say what? Python 3. Hello world.py. Okay, now it runs it in Python 3. Does it matter when you are just writing hello world? No, it doesn't. But does it matter a whole lot? In other cases, yes, it does. So make sure that you're running under Python 3, 3.7 there, and you do that by running under Python 3, like I just showed you, okay? Well, that is pretty good, but let's come back over there now, and let's go back, and if I hit the arrow key, I can get my old commands back quickly. And so I am going to nano hello world.py. It brings it back up. I really don't want to say hello world anymore. Let's just see if we can write some code here. So I'm going to say x is equal to 7. I'm going to say y is equal to 2. I'm going to say z is equal to x plus y. And now let's see if I can do a little bit fancier print. I'm going to say print. I'm going to string things together, and you string things together separated by a comma and being mindful of whether you're printing a string or a variable. And so what I'm going to do is I'm going to print x, and then I'm going to print the string. Okay, so x comma to say it's something new, and then I'm going to print the string space, put a space, and now the plus, and now a space. Now I'm going to end that string, and now I'm going to print a y, and then I'm going to print another string, and that string is going to be space equal space. I'm going to end that string, and then I'm going to print z like that. Okay, so this should say like 7 plus 2 equal 9. All right, so let's Control X, yes, enter. And now I'm going to nano, I'm going to Python 3, hello world, and look at that. Boom, 7 plus 2 is 9. Okay, so we did a little bit fancier formatting there. Let's go back and let's nano hello world again. And that's kind of neat, but you know what I could also do is instead of printing x plus y, I could print it as a string. So I could say the string x plus the string y. Now I'm confused. The string somehow that got confused. Okay, the string y, and then comma, and then the string z, or the string equal. So I'm going to say the string x, the string plus, the string y, the string equal, and then z. Okay, Control X, yes, enter, and then we're going to Python 3 that one again, and there it says x plus y equal 9. So you see, I could say 7 plus 2 equal 9, or I could say x plus y equal 9. I'm just trying to show you a little bit about how you can string things together with that print statement. Get some nicely formatted output on your code, and so that looks pretty good. You could also come up here and you could just make it easier. If we'd done this from the start, we would probably have just made one string, and that one string would be x plus y equal, like that. Okay, and then Control X, yes, enter, and then let's Python 3 it. And then you see we get the same thing, x plus y equal 9. It was just a little bit easier way to do it the second way that I showed you. All right. And so now let's go back in there and let's play around with some more things. And so what's the problem here? Well, that's kind of a neat way to add two things together. But let me just show you, like if you want to multiply, how would you multiply? Well, you use the Shift 8, you use the star. And then this would be like this. This would be the star, okay? And now Control X, yes, enter. And then let's go Python 3. And then in that case, you say x times y is 14. 7 times 2 is 14. So that looks good. So that is how you multiply. You use the little star. Okay, now how do you raise something to a power? So if you wanted to say 7 squared, how would you do it? I'll be honest with you, I don't know, but let's just say if you do star star, that's the way it was in Fortran. Okay. I really shouldn't do these things on the fly. Look at that. X to the y is 49. I'm kind of relieved that that worked, because I really hadn't done that in a while and I didn't know if that would work or not. Okay, so that looks good. Let's nano it. Okay, so the way you raise something to a power, it is the star or asterisk asterisk. So that would be x raised to the y, that would be 7 raised to the 2, and so that would be 49. Well, I wonder how you would take the square root of something. Well, you kind of do it with math. You would sort of take that, you would do it with math. Let's make 9. That was just crazy what happened there. Okay, let's make it 9. Okay, guys, what I should have told you is the mouse doesn't really work. The mouse doesn't really do anything. You can highlight stuff, but you have to use your up and down keys to move the cursor. You see, I can't click up here and move the cursor. The cursor stays down there, so that's not good. Okay, and so let's come here and let's kind of put the star star like we're raising something to a power. Well, how would I take the square root of 9? Well, that would be 9 raised to the 1/2. So if I said 9 and I said y is 1 divided by 2, okay, then x raised to the y would be 9 raised to the 1/2. And if I'm thinking about this right, that should be 3. So let's Control X, yes, enter, and then let's run it, and boom, square root of 9 is 3. Okay, so guys, these are just really important things. We can add, subtract, multiply, divide. Divide is the slash. That's pretty obvious. And then what you can do is you can raise something to a power. If you want to take the square root or the cube root, it'd be like raised to the 1/2, raised to the 1/3. If you want to take the 4th root, it would be raised to the 1/4. So this stuff is pretty good. Let's come back in here and see if there's any other simple math. And so that's kind of the basic math that you need. There's a lot of different math functions, but you can figure those out as we're going along. And so let's look at that divide. Okay, so let's say that x is 1, and let's say that let's make x 1. Okay, and now let's make y 3, and then let's say z is x divided by y, and then let's come down here and we will say x divided by y is z. Control X, yes, enter. And now we're going to Python 3 that thing. And what it says is x over y is 0.3333333. What is the problem with that? That's like way more precision. Like if you're running out and you're making a temperature measurement or something like that, and your sensor is good to 1 or 2 decimal points, don't print things out to 57 decimal points because your instrument that's making the measurement doesn't have that level of resolution. Plus, it makes it really hard to read. So how would we fix that? We would come in, and what I would do is I would come over here and I would take Z and I would print the rounded value of Z, and I would round Z to 2 places. So I'm going to RND, I'm going to round Z to 2 places, but now I still need to come in and I need to close out my print. And so this closes out the round function, this closes out the print. And then balancing your parentheses are really important. One of the hardest things to debug in coding, and one of the most common problems I see with students who are working, is not getting their parentheses balanced. And when you do that, a lot of times you get sort of strange errors. Let's do it the wrong way. Let's say I hadn't closed that out, and let's see what happens. Okay, let's run it the wrong way. And then what it says is, hello world pi.7, unexpected end of file while parsing. Unexpected end of file while parsing. That is not exactly very descriptive, and you wouldn't really know what to think. So you can, when you don't balance your parentheses, you can get strange error messages. Okay, let's hop on up. Python 3, hello world. Ooh. Round is RND is not defined. I taught you wrong. Isn't that terrible? I taught you wrong. Maybe it is round like that. Round. Control X, yes, enter. And now we'll Python it, and you got to spell round right. Oh man, I'm falling apart here. Okay, R-O-U, no Y in round. Okay, now Control X, yes, enter. Oh, I think I hit the Y for yes, and I think it put it in there at the wrong time. Okay, so now we will Python 3 it, and there it is. X over Y is equal to 0.33. See, that looks a lot better. Now, the other thing that you could imagine that you could do over here, you could come up and you could say something like, right here, you could say something like Z is equal to round of Z to 2 places. Okay, but you see, I don't like to do that. I like to carry that extra precision along with me just in case there's any meaning in it, and then I just get rid of it when I print it. But you see, like, let's say that, let me show you here what would be wrong. Like, what if I said Z is equal to round Z of Z over 2, and now I don't need to round it here, so I would just print Z. Like, I would print Z like that. And then if I came in and said, okay, Z is equal to Z times 3, and then print Z, Control X, yes. Okay, so you see, it says x divided by 3 is 0.33, but I rounded it off, and then I say what is 3 times that is 0.99. So now all of a sudden I've got an error in because I actually chopped that number off. So I don't want to chop that number off. I want to keep the full precision and only print a chopped off version of it, but I don't want to chop the number off itself, if that makes sense. Okay, guys, we need to keep on moving here. We need to keep on moving. And so what I'm going to do is I'm going to come back and I'm going to go back into that program, and let's just, I'm just going to back over all that sort of stuff. And let's say, what was the problem with that? Well, like if I wanted to add 2 different numbers, what do I have to do? I have to go in and I have to edit the code. Well, what would you like? You would like to be able to get input from the user. So how do we get input from the user? Let's say that I say X is equal to, and now instead of saying X is equal to 3, I'm going to get it from the user, from the keyboard. So I will say X is input. And now inside the parenthesis, I need to give it a command prompt. Input your first number in the string in the quote. So it's going to tell the user input your number, and then it's going to put that number that they input into X. Okay. Now Y is going to be input, input, and then I'm going to say input your second number. Input your second number. Okay, like that. Close it right. And now I'm going to say Z is equal to X plus Y. Okay, now I'm going to print. Again, this should make sense. I'm going to print. X, comma, and then I'm going to put the string space plus space. I'm going to close that string, and then Y, and then I'm going to put X plus Y, and then I'm going to put the string. I'm going to put the string space. I'm going to put the string space equal space, and then I'm going to print Z like that. Does that look good? I think that looks good. I did forget a comma there, like that. I forgot the comma. Okay. Control X, enter. Okay. So now let's try running that. Nano, I want a Python 3. Okay, input your first number. Well, I'm going to put 3. Okay, input your second number, 2. Now tell me what this is going to do. Say it out loud or put it in the comments down below, or on the Premiere, put it in the chat. What is this going to do? Say what it's the output's going to be. Okay, if you said 3 plus 2 equal 5, you would be wrong. 3 plus 2 equal 32. Somebody tell me what happened. Somebody tell me what happened. Okay, this is what happened, and it's what I warned you about. You assumed when you input something from the keyboard that it was going to input 2 as an int, but it didn't input 2 as an int. It input it as a string. So it was the string, the character 2, and then the string, the character 3, and then in the string world, what is plus? Plus is concatenate. So let's take a look at that. Let me control X out of this. Let's go back and just say Python 3. Okay, so if I say X is equal to, I'll make it the string 3. Okay, and then Y is equal to the string 2. I'm making it that deliberately here, and then I say X plus Y. X plus Y is the string 32. Okay, so the inputs things as characters or strings, and the plus in string world concatenates. The plus in string world concatenates. So I could say X is equal to hello, okay, and Y is equal to space world, like that, and Z is equal to X plus Y. That plus is an addition, it's concatenation now, and now Z is hello world. Okay, does that make sense? Man, you see, I'm telling you the mistakes that you're going to make, and these things are really terrible, and sometimes you get these errors in Python that are so hard to figure out what went wrong. So I'm trying to kind of deliberately show you some of the pitfalls. Okay, let's go back. Let's go back and say nano hello world. All right, so we got that figured out. So what do we need to do? Well, what we could do here is we could change them to int. So I could say X is equal to int of X, like that. And then I could say Y is equal to int of Y. And now Z should get it right this time because I've changed them to ints. So now I'm going to do a control X, yes, enter, and now let's Python it. I nanoed it. Okay, what is that? I'm going too fast. I need to slow down. Take a deep breath. Take a sip of coffee. I'm going too fast. All right, so we're going to nano it. Nano hello world. Okay, that looks right. We're going to control X, yes. Now we're going to Python it. Okay, we're going to Python it. There it is. Okay, enter your first number, 3. Enter your second number, 2. And then you have 3 plus 2 is 5. Okay, does that make sense? Let's go back and change it. I'll show you how I would usually do it. Rather than coming down and doing these extra lines of code, I would force it when I read it. So I'm going to say that x is equal to the int of input. And that will take that string, and right when you read it, it will change it to an int. Okay. Like that. And then Control X, yes, enter. And now let's Python that. Okay, now we say 3, 2. 3 plus 2 is 5. Okay, that works really good. Now, if we wanted it to be Python nano, if we wanted it to be a float, we would write here, say float like that, and then we would say float like that. Control X, yes, enter, and then let's run it. Okay, now we're going to say 3. Notice I'm entering it as an integer. 2, I'm entering it as an integer, but then it says 3 point plus 2 point is equal to 5 point. So it's changing it to float based on that float command on the input. So hopefully that makes sense. All right, guys, we've gotten pretty good here. We've gotten pretty good with variables, but what we need to do now is we need to work on conditionals, like our if statements. Coming from the Arduino world, you understand if statements, but let me just show you how they are done in Python because it's a little bit different. So let's nano hello world. And so let's just say, let me get rid of all this. I'll keep my first x input, and I'm going to input it as an int, and then input your, instead of first number, just number. Okay. Now, how do I do an if statement? Well, I can say if, and then I can say if x is greater than 0, okay, then in Arduino, the way you start your clause with an if statement, you start it with a curly and then you end it with a curly. Okay, in Python, it's not that way. The if statement is followed by a colon. And then how long are you in the if statement? As long as you are tabbed over. Okay, so I can say if x is greater than 0, I tab over, okay, and then I would say print your number is positive. Okay, now I could also say print I like positive numbers, and tell me the mistake I made up there. I did not close my string up there. Okay, now that should be good. So if x is greater than 0, it's going to say your number is positive and I like positive numbers. The second print statement is still part of that if clause because it is indented. Okay, but here, now this isn't indented, this is breaking out of the if statement. Now I could say if x is less than 0, then what do I have? Well, I'm going to tab print your number is negative, like that, and then close it. Okay, and then print I don't like no negative numbers, like that. Okay, now let's Control X, yes, enter, and now let's run that. Python 3. Okay, input your number 2. Your number is positive. I like positive numbers. Okay, then I could, okay, you could see that the less would work then. Yeah, let's go ahead and show it. Okay, so now what we would do is we would Python 3 it, and then input your number -4, and you could say your number is negative. I don't like negative numbers. Okay, so you can kind of see here how to do conditionals. We're starting to learn the conditionals, and what you see is the if statement is lowercase I on the if. What you can see is you need to, on that line, put a colon, and then you stay in that if statement as long as you stay tab, but the tabs have to be exact. And don't do it by putting spacebar, spacebar, spacebar. You need to use a tab. Okay, one tab to indent over. Like if I put another tab there, the thing is going to crash. It's not going to work. You have to tab, and you have to tab everything where it lines up. How does it know when you left the if statement? You've leave the if clause when you stop indenting. Okay, so that is pretty good. I'm trying to think. Okay, let's try. Let's try. What did I do wrong here? Okay, and this is what I did wrong. I did not cover the parameter space of possible answers. What did I leave out? I left out 0. And this is why, like, I don't like else statements. Okay, let me show you why I don't like else statements. This is the type of thing you do. All right, this is why I never use else statements. And it's something that I argue with you guys about. Oh, well, instead of using 2 if statements, I just used an else statement. Okay, so you would say if x is greater than 0, then you print that. Else, okay, else you print this. Okay, that's great, right? That's the way you guys would do it. You guys that love the else statement. Okay, so now let's run it. Okay, input your number 3. Okay, your number is positive. I like positive numbers. Okay, and then didn't mean to do that. Python 3. Okay, input your number, negative 23. That's fine. Your number is negative. I don't like negative numbers. Okay, so everybody's happy, right? Everybody's happy. You and your little else statements, you guys are all happy. What if I put a 0? And then you say your number is negative. I don't like negative numbers. Why? Because 0 isn't negative, and it's because you used an else statement, and then you get this unexpected result in an area that you weren't thinking about. Okay, so let me show you why I use if statements, because if statements can be used to completely cover the parameter space. Well, the number could be greater than 0. Okay, the number could be x is less than 0, okay, like that. And then what is the other possibility? If x is equal to 0, okay, then what do? You print your number is 0. Because I'm not going to argue about whether 0 is positive or negative. You could do that. Do you see how much cleaner it is? Let's think I can go from negative numbers all the way to positive numbers. What is every possibility? If x is greater than 0, if x is less than 0, if x equals 0. And in fact, if I were coding, I would make it even more explicit. If x is less than 0, if x is equal to 0, if x is greater than 0, and I would even put my if statements in order to completely cover the parameter space. Now, I know some of you guys are going to jump in and start saying, oh, well, I could do it with an else statement. No, just use if statements just to make me happy. Stop using else statements. Causes problems. All right. Now, I have an error in this code, and what is the error? Somebody tell me the error. Okay. If you want to go greater than, the condition is greater than. If you want to go less than, the condition is less than. But what is going to happen when Python sees if x equals 0? Well, let's just run this. Okay. So I'm going to run it, and I'm going to say, it actually found it, darn it. I was hoping that it wouldn't find it. But it found it. Okay. What it is the condition on if x equals 0, you have to do equal equal. If x equals 0, you have to use 2 equals. If it sees x equals 0, it thinks you're setting it to 0. You can't do that. You have to use equal, equal. And I was surprised that Python found the error. Usually it behaves in an unusual way. I think Arduino doesn't find that one and behaves in an unusual way. But for an equal condition, you have to go equal, equal. So now let's go Control X, yes. And now let's go Python 3, and let's go 0. And then it says your input your number 0, your number is 0. Okay, and now it works for all the different possible cases. Okay, let's jump back up here and let's kind of keep learning. Let's keep this learning going that we are doing. So so you can imagine, besides greater than, you can have greater than or equal to, you can have less than or equal to, you can have also the not, like you could say not equal to, and not is the exclamation point. So you could have not equal to would be exclamation point 1 equal. So those are your conditions. But sometimes you might want a compound conditional where you have more than one condition in one if statement. So let's see, like, how would we find out if the number is even or odd? Well, I could say z is x mod, I'm panicking because I can't see, there it is, okay, x mod 2, and what the mod function does is it gives you the remainder. So 4 mod 2 would be 0 because there's no remainder. 3 mod 2 would have a remainder of 1. Okay, so mod is the remainder, and that little percent is the mod. Okay, now what I could say is if x is greater than 0 and z is not, or if z is equal, if x is 0, that means it's positive, and z is equal to 0, what would that mean? That would mean your number is positive and even. Positive and even, like that. And then I'm going to take this other nonsense out. Okay, and now I could also, and what I'm going to do is I'm going to copy this, and what you can do is you can come across and then copy, and then you come back here, and this is going to be almost the same. And Control V does not paste, and so you're going to have to right mouse click and paste like that. Okay, so now if x is greater than 0 and z is equal to 0, then your number is positive and even. What if the mod is not? What if the mod is not equal to 0? Then what would that mean? That would mean that your number is positive and odd. Okay, like that. Now I'm trying to think. I think I'll just change this as if x is less than 0 and z is equal 0, then what does that mean? Your number is negative and even, and then get rid of this nonsense. Even, like that. And I better close that string. Okay, and then here, if x is 0, print your number is 0, and I'm not going to argue about positive or negative or even or odd. I'm just going to say your number is 0 in that case. Now the one other one we have to do is say if x is less than 0 and z is not equal to 0, then what do we have? We have the case of print your number is negative and odd, like that. And now we've got the less than, the greater than, and we've got the 0. So I think using our friendly if statements, we have the whole range of possibility covered. Did I get that all right? Okay. Control X, enter, or yes, and then enter. Okay, now let's run it. Python 3, Okay, input your number 3. Your number is positive and odd. Let's run it again. 4. Your number is positive and even. And now let's come up here and say -8. Your number is negative and even. And then let's say -7. What? Okay. We got an error. Hopefully you guys caught it when I was doing this. And what you can see is I misspelled print. And that's another thing. If this had been a compiled language, it would have found this. But here it doesn't find it until you actually run that line of code, which means you really have to be careful when you're debugging your code in Python. Okay, so now let's try that -7 one again. Okay, so -7, and your number is negative and odd, and then one more will be checking the case 0, and it just says your number is 0. Okay, so boom, we got that done. So you understand conditionals, you understand variables, you understand arrays, you understand if statements, you understand compound conditionals. We are learning a lot here. Let me show you something I did really poorly. Do you see on all of these things, like if you look up here, how when I answered, it would run my answer into the question? And I should have fixed that very early on. You see, when I say input your number, I didn't leave any space. So it would have been good to do something like a colon and then like that. And now Control X, yes. And let's just try the 0 case again. And Control X, yes. Okay, let's do the Python 3. Let's do the 0. And you see now, because I put the space on the prompt, now it's not running the answer into the question. Okay, so now let's go back to our program, Python 3, hello world. You want to nano it. There it is. Okay, so what we did there was we got our conditionals done. You know, one thing is, don't you kind of wish that you didn't have to run the program every time? Well, I'm going to show you how to do a while loop. Okay, so I'm going to come here, and then I'm just going to say while. Okay, and then while 1 equal 1. Now, how do I start the while loop? Just like the if statement, you start it with a colon. How long are you in the while loop? As long as you are indented. So if I want these things in the while loop, I've got a tab, but now I've got to tab the print, so it will be inside the if statement. And then I'm going to tab the if statement, tab its print. You kind of see what I'm doing here. Okay. I'm tabbing all of these things over so they'll be inside of the while loop. Now what's going to happen? When does 1 equal 1? 1 always equals 1, and so that's an infinite loop. And so now we are going to run that. It says input your number. My number is 3. Ooh, that is crazy. Something happened here that I was not expecting. Control X, Control C. Okay, Control C killed it. What did I do? What did I do? Okay. The input was not in the while loop. And therefore, once it got a number, it just kept going through printing. It never got another number. And so I was being careless there. And that while loop should be at the very top up here. And I should say while 1 equal 1. There's my colon. And now what do I need to do? I need to tab these over to be in that while loop as well. Now Control X, yes, enter. And now we're going to say Python 3. And what's my number? 3 is a positive odd number. 2 is a positive even number. 0 is 0. 3 positive odd. -3 is negative odd. Minus 28 is negative and even. Boom. Okay, so you see we can do our conditionals. And I've also shown you how to do a while loop. A while loop, let me, I need to do like a Control C. Control C will kind of get you out of your program. So let's go back and let's edit this now. So you see the while loop will loop as long as the condition is true. So as long as the condition is true, it will loop. And so let's just kind of do, like, really just do one while loop here, just to make sure you know how to do that. This is really amateur hour here, how I'm erasing with the backspace key. But let's say x is equal to 1, and then I could say while x is less than or equal to 10. Okay, then I'm going to tab, and I could say print x. Okay, and so as long as x is less than or equal to 10, I'm going to print x, and then inside the loop I'm going to say x is equal to x plus 1, and then it should go all the way up to 10, so it should print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to control X, yes, enter, and now let's run it. Nano Python 3 hello world, and there it is. Boom, 1 2 3 4 5 6 7 8 9 10, a while loop. It loops as long as your condition is true. It loops as long as your condition is true. And so as long as x was less than or equal to 10, it looped. And then when it was not, you could say print, and then I could print that's all folks, like that. Close it. Okay, so now let's control X, yes, enter. And now what's going to happen is I misspelled print again. That's twice. Man, I need a dollar jar. I got to put a dollar in every time that I misspell print. Believe me, I'm hitting the T. It's a wireless keyboard, and the T is not making it. Control X, yes, enter. Now let's run it. Python 3, there it is. 1 2 3 4 5 6 7 8 9 10. That's all, folks. Let's nano it. Okay, so why did it just print it once? Because it wasn't tabbed. After you went through the loop, then the first command that wasn't tabbed is not part of the loop. Now if we tabbed it, what's it going to do? Somebody tell me what it's going to do here. If we tab it over, every single time it's going to print it because it's in the loop. Okay, so now we have done conditionals, we've done variables, we've done arrays. Let's do a simple program that does a for loop and also sort of see how you can populate an array in Python. So we are going to nano hello world. We're going to do our amateur hour back over this other stuff. And let's just get a list of grades from a user. Okay, so I'm going to say num grades is equal to int, because I'm going to read it as an int, and then I'm going to input it, and I'm going to say how many grades do you have, like that. Okay, close the string, close the input, close the int. All right. Now, what am I going to do? I want to go in a for loop. Okay, I want to go in a for loop. I better just do a for loop to begin with. Okay, how do we do a for loop? For I, you could call it anything, but I'm going to use my counter. My index is going to be I, and I'm going to say in range. For I in range, I'm going to start at 0, and I'm going to go to 10, and I'm going to go in steps of 1. Okay. And then I am going to tab. So the for loop, what's inside the for loop is what is tabbed over. So do you see if statements, for loops, and while loops? They all have this colon here. And then you are in that as long as you are tabbed. So now I'm going to say print I. Somebody tell me what this is going to do. This is going to count from what to what. Okay? Count from what to what. Somebody leave a comment. This is going to count from what to what. And if you said from 0 to 10, you would be wrong because it's going to stop at 9. And let's look at that, because this is one of the biggest problems in Python that I see. Okay, so you say go from 0 to 10, but it didn't go to 10. It stopped at 9. It stopped at 9. Now, why did it do that? Because it figured if you need 10 numbers and you start at 0. So it's sort of this crazy thing of how programmers start at 0 And so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is actually 10 numbers. And so it always stops one before because it assumes that you're starting with 0, if that makes sense. But if you wanted to actually count from 1 to 10, how would you have to do that? You would have to say, go from 1 to 10 in steps of 1. That would stop at 9. So you have to go one more than that, 11. Okay, now let's try that. Okay, so then it goes to 10. Okay, let's let me just show you the way that I like to do a for loop. Okay, let me show you the way I like to do a for loop. And the way I like to do the for loop is, I don't like this range thing because I am always confused. What I like to do is I like to use our friend NumPy. And so what I'm going to do is I'm going to say import NumPy as NP. So what did you just learn? You learned how you can import a library, and that library will give you access to new functions that the normal Python wouldn't let you have. So let me just start by saying import NumPy. Okay, now what I could do is here I could use a function that NumPy has that's called linspace. Okay, and so I would say I want to use the library NumPy dot linspace, and linspace says, where do you want to start? I want to start at 1. Where do you want to stop? I want to stop at 10. How many points do you want? I want 10 points. And so it's like, start where I want to start, stop where I want to stop, and give me the number of points that I want. All right. Do you see that linspace? I have start, stop, and number of steps. Okay. So let's run that. Boom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see why I love linspace? I love linspace because I told it where to start, I told it where to stop, and I told it how many steps. And I could come in, let's say that I want to do 20 steps. Okay, what happens there? Somebody tell me what's going to happen. Look at that. It's going to go 1 point. Okay, it's kind of counting in halves, but I'm kind of confused here. Let me see. Unexpected result. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm just confused why that came out kind of rounding in a strange way. Let's look at that. Okay, I want to start at 1. And I want to go to 10, and I want 20. Am I thinking about this wrong? Maybe I should have done 19, and it will go right. Yeah, okay. 1, 1.5, 2, 2.5. Okay, so I got the number of steps wrong in order to make it end up even. But you see why I love linspace? You say where you want to start, where you want to stop, and then how many points you want in there. Okay, so let me show you. We learned how to import a library by saying import NumPy. Who's your friend? NumPy is your friend. But now every time I want to use NumPy, I'm going to have to say numpy.this and numpy.that. I can import a library and give it a new name. So I could say import NumPy as NP. And now anytime I want to call NumPy, I just call NP. And that makes my programming a lot easier. So I can now say Control X, and then I can run that. Oops, Control X, enter. Now I can run that, and boom, you see it works just the same. So that's kind of a little pro tip there. You can use linspace, you can import it in NumPy, and you can import NumPy as NP. As we need to wrap this thing up, there's one more thing I need to show you. Let me show you how to populate an array using a for loop. So we will come back up here now, and we will nano this. And what we're going to do is we're not going to use that anymore. Amateur hour by backing over my old code. Okay, so now what I'm going to say is, how many grades do you have? Num grades is equal to int, and I'm going to get it from the keyboard. So I'm going to input, and then what I'm going to input, how many grades? Question mark space, close the colon, close the input. Close the string, close the input, and close the int. Now I'm going to say for I in range. Okay. I better create my array, right? I'm going to say x is equal to what? An empty array. All right. X is an empty array. Now I'm going to say for I in range. Okay. And where am I going to start? I'm going to go start from 0 to num. Great. My goodness, what did I hit? I don't know how to get out of this. I hit a control something unusual. So let's see if I can control X. Okay, it got me out. Okay. For I in range, I'm going to start at 0. I'm going to go to num grades. Okay, and then I'm going to go in steps of 1. Now you might say, well, wait a minute, you're not going to make it to num grades. Well, I don't want it to go to num grades since I'm starting at 0. I want to start 1 before num grades, which is how this works. You can kind of see that it makes sense now. So if I say 10 grades, it's going to ask 10 times. It's going to go through 10 times. It's going to start with 0 and stop 1 before num grades. And so I hope that makes sense. Okay, so now what you might think is, you might think that you would make x is equal to, or yeah, you might say, now what I need to do is my grade is going to be equal to, input, and I better make it an int, so I'm going to make it an int, and then I'm going to say input your grade, and then I'm going to close the string. I'm going to close the int, and I forgot to say input here. Input, open. Okay. Now, that closes the string. That closes the, man, this is amateur hour here. Okay. So this is make an integer of the input. And now, close your string, close your input, and close your int. Now, I've got my grade, but how do I get it into x? Well, you could think, you could say that x sub I is equal to my grade. And if you thought that, you would be wrong because of what I showed you earlier. You cannot index something that isn't there already. So the way we would do this is we would have to say x dot append. And what do we want to append to x? My grade. I really wish we could index things the way that I showed you is the wrong way. Some languages you can do that, not in Python. Okay, and so now I should have it there. Now what I could do is I could say for I in range, and I could go from 0 to num grades in steps of 1, and then what could I do? I could print, and I could print x of I like that. Okay, and so now let's run that. Let's see, x of I. Let's run that and control X, yes, enter. Okay. How many grades? 3. I'll have 70, 80, 90. Okay. Ooh, line 7. L is not, it's out of range. What did I do? What did I do? And I'll tell you why I did it, because it's a real common error. When you are using I, an I looks a whole lot like a 1, and it looks a whole lot like an L. And so you see, I put a typo in here. I didn't say print X of I. I said X of L. That needs to be an I. Actually, here with the font in this terminal, they really made the I and the L distinct, but in a lot of programming environments, the I and the L and the 1 all look very, very similar, and it is a mind-numbing. It is a mind-numbing problem to try to debug that because it looks so right. So let's go X, yes, enter. And now let's go Python 3, hello world. Let's say 5 grades. I'll make a 99, a 98, a 45, and a 100 like that. And so let's see, that's 1, 2, 3. This is the 4th grade, and then it is going to get a 97. That is the 5th grade. So you see it counted correctly, and then boom, 99, 98, 45, 197. So this crazy start at 0 and go to num grades but stop 1 before it. It actually does kind of work. It does kind of make sense. Let's just come in here and we could make this a little nicer. That did not mean to do that. Okay, let's go and nano it. And we can come up here, and after we input the grades, we could come here and say print, and then say your grades are, like that. Okay, close the string, close the print, Control X, yes, enter. And now we are going to Python 3 that. How many grades do you have? Let's say 5. I'm going to say 91, 93, 95, and I'll say 92, and then 97, like that. And then it says your grades are 91, 93, 95, 92, 97. What do you not like? I hope you guys were yelling at me. What should you have been yelling at me? Do some nice formatting there. Don't do that. That's Bush League stuff there. That's Bush League stuff there. Let's come in, and when we input something, you see how nicely we did it up here, okay, with the space, but we didn't do that here. So what we say, input your grade, we could just put a colon and a space, and then that will make it nice. Let's just try that to make sure. We'll say Python 3. Python 3, hello world. Okay, 2 grades. Man, I don't know what that was. 2 grades, 99 and 96. And it says your grades are 99, 96. Boom. Okay, that's pretty nice. That's pretty nice. That looks pretty good. Guys, this has been a long lesson, but I really wanted to just blast through. I wanted to blast through this in one sitting. And so let me give you your homework assignment. What your homework assignment is for next week is to take this, okay, to take this program. And what I want is I want you to have 3 for loops. The first for loop inputs the grades. The second for loop averages the grades. And the third for loop prints out the grades. And then down at the bottom, it say, and your average is. So you're going to input the grades, you're going to average them, then you're going to print them all out, and then you're going to print the average. That is your homework for next week. Leave a comment down below if you're able to do the homework. Leave a comment. I am legend. If you're not able to do it, leave the comment. I fold it up like a cheap Walmart lawn chair. So I need you guys to be doing this homework, and averaging grades is kind of a classic problem you learn. It sort of allows you to learn a lot of the stuff that we did in this lesson. So let me Control X out of here. Let's get over here now that I have given you the homework assignment. Let's get over here to our river view, and friendly fisherman out there. We haven't seen the fisherman in a few days. It's a beautiful morning out there on the Nile. You can see that we've got a little clouds building up. We probably get a rain this afternoon, and this fisherman is using his paddles. Okay, very nice. So what have we done in 3 lessons? Lesson number 1, you laid the foundation. You can get your Pi booted, and you can find your way around the desktop. Lesson number 2, you learned the essentials of Linux. You can work your way around the terminal. Now, you notice as I was doing all this stuff in the terminal today, it was easy. You guys were familiar with it because you learned the terminal last week. Today, we learned Python. Next week is going to be the day that we start working with the GPIO pins. And the GPIO pins are a lot like the Python digital and analog pins, only, I mean, the Arduino digital and analog pins, but on the Arduino, it's just like you just do a pin mode, and man, you just do whatever you want with those pins. It's a little more subtle with the Raspberry Pi. You've got to kind of set those things up a little bit better. And so we'll start next week by showing you how to understand what all the different pins do and how to configure them. And then, of course, we will be busting into the most excellent Sun Founder ultimate Raspberry Pi kit, and we're actually gonna turn some of these pins on and see if we can hook them up to some stuff in the kit. We will see if we can hook them up to some things in the kit, and that will be lesson number 4. And then as these series of lessons go, we're just going to be connecting more and more complicated components to the Raspberry Pi. And then we're going to be doing more and more complicated analysis and data handling and more like graphical types of things with the data. And so we're just going to start by like reading something and printing it, or sending a simple command to turn something on or off. And then as the lesson goes on, as the lessons in this series goes on, we will just be doing more and more complicated things. And what are my goals? My goals are for you, number 1, to learn to think like an engineer. Number 2, to learn to code. Number 3, to learn some math. And number 4, most importantly, is to have some fun. I really, really want to make this fun. Math and circuits and programming and projects can be a whole lot of fun. It's just we sort of learn to hate math and we learn to hate things when we're in school, but we're going to learn to love those things. And I promise you, above all, this is going to be a fun class. So remember, next week we will get into the kit. Link down in the description. Make sure that you order it now so you'll have it next week. If you like this video, make sure to give it a thumbs up, because that helps us with the old YouTube juice to have people give it a thumbs up. It will show this to more people. If you have not already, make sure that you subscribe to the channel. When you subscribe to the channel, make sure that you ring the bell so that you will get notification when future lessons come out. And then share this with your friends and family. Share this with other people, because the world needs more people doing engineering and coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.